this is Ebonygeek. You're always welcome to join me in expanding your knowledge base. Comments are always welcome, and please subscribe. Hello, this is Ebonygeek45, and today is a great day to learn something. What we're going to be learning today is about electronics calculations. Of course, like I said, we're going to be doing tutorials on Arduino. And yes, we are talking about Arduino. A big part deals with electronics components. And so we need to learn how to calculate those components and how we use it so that we don't wind up doing things like damaging our components. We're going to be dealing first off with LEDs. This is a picture of an LED. And if you don't use a resistor with an LED, then what's going to happen is that LED is going to blow out as soon as you get it hooked up to the power supply. So you need a way to protect that LED, and the way to protect that LED from the power supply is the resistor. Okay, so let's go ahead and go through what I have set up for you, because I have a few little presentations to show. So let's say that we have, of course, a LED that we use 30 milliamps. Okay, our power source is a 9-volt battery. What will be the value for the resistor? Well, that's what we will need to find out, and we have calculations to find that out. So we have a formula here for resistor when we don't have the value for the resistor. Now I'm gonna bring up what I call the diagram of the Ohm's law diagram. Okay, now I might be wrong, don't shoot me if I am. That's how I remember when I was researching it. Now this is a pretty handy little diagram, because it's showing you, like, say we don't have the resistance or the value for our resistor, but we do have the value for our voltage and our current. So it's telling us, okay, if you have your voltage and your current, then those two divided will equal the resistance that you need, the ideal resistance that you need. You can also see it here, which is what I like about this, because if you say put your finger over the R, you will see that you would need to divide voltage and current, and that would equal your resistance. So like, say if you put your finger over the I, you would know that you would need to divide voltage and your resistance to get your current. And like, say if you put your finger over the voltage, you will know that you would need to multiply your current, which is here, with your resistance, which is here, to get your voltage. That's what I like about this diagram. It gives you a way to go no matter which type of issue you find yourself in. So to explain this a bit, and trying to get the right size here, VR voltage is how far electricity can travel. I, which confused me a lot because I saw I and I'm like, well, what the heck is this? Well, that's your current. It's the work the electricity does when it gets there. Okay, so like, say our current here, if you go back to it right here, our current is going to be the 30 milliamps. And what it was saying is that it's the work that it'll do once it gets there. And what our chart here says, that what our current will do is the work that the electricity does when it gets there. Okay, well, our LED is going to light up. That's the work that the electricity is being put towards. Your voltage is how far the electricity travels. So your battery is going to send out electricity to your LED, and that's how far it's going to travel to the LED, and then the LED is going to do the work, right? Now, the resistance is how you control the electricity. So when we send this current, or this voltage, I'm sorry, when we send the voltage to our LED so it could put it to work using that current that it's getting, then we need a way to control that voltage. So like I said, when it gets there, it doesn't overwhelm the LED and blow it out. So the way we would do that is to use a resistor. Okay. Now the resistor is going to control the current that's going to our LED so that our LED will be safe, or it's going to protect our LED from getting too much. Okay, so if you could understand that. The resistance is the one out of the three that can change. Okay, so we know that our LED is 30 milliamps. We know that. That's not going to change. That's how the factory sent it out. That's the same thing with the 9-volt battery. That's not going to change. That's the way it's sent it out. So, well, I guess you could actually use a different voltage of a battery. But the resistor, that's what it's for. You would use different resistors in order to control the electricity so it doesn't blow out the LED. Okay, so now that we have that figured out, we're going to go ahead and go down to the calculations, okay? So, our resistor equals our VS, which is voltage supply, okay? Divided by IF for current use, or current for use, divided by 1000. This is what this is explaining, okay? So we have our voltage supply, that's the battery, divided by our current used, which is our LED, divided by 1000. 1000, well, that's just the amount that is divided by. I researched it a long time ago. I can't remember what that is, but okay, but it's 1000, okay? So your first step is to take care of your parameters, and that's going to be the 30 divided by 1000. Now that's going to translate out to your resistance equals 9 divided by 0.03. 30 divided by 1000 is 0.03. Okay, now you even got a little handy dandy diagram for that. Now, so you have your 30 divided by 1000, which equals 30 over 1000. Okay, dot to dot and blah blah blah, and the answer is 0.03. Now, and like I said, if in doubt, use a calculator, which you see it says 0.03 right there. Okay, so going back to our little script here. So first you're going to take care of your parameters, and we figured out that 9 divided by, or 30 divided by 1000 translates to 9 divided by 0.03. This is just basic calculations. This is stuff that we learned in school that we thought we would never use. I remember saying, I'll never use that, and wound up using that. Okay, so once we have our calculations set down, then the next one we need to do is 9 divided by 0.3. And of course, if we go back here, we're saying 9 divided by 0.3 equals 9 over 0.3, and we calculate it out to 300. Okay, that's simple math. That's simple math. Okay, so now once we get that done, okay, where are we at here? 9 divided by 0.03 is going to be 300. Okay, now what is going to look like here is we have our R equals 300, and this is ohms. So your resistance is going to be 300 ohms. That's the ideal resistance for your resistor that you're going to use. So we'll have a value to do we have our values to do our first project, which is our LED that we're going to get. And this is what we need to get together. Our LED is going to be 30 milliamps. Okay. Our power source is a 9-volt battery. Now, this can change, which is what I was about to say before. This can change because it depends on what power supply you set up to use with your Arduino and with your system. It's pretty much your choice on what power supply you will use, but that's something that you will have to decide. You don't want to get something that's going to be too powerful for your Arduino. Here's the kicker right here. You could just simply, if you had a Uno, which is what we're going to be using, that's what we're going to be using. So I would suggest that you use it. If you have a Arduino Uno, use the USB cord to plug into the USB port, and that will be your power supply, and you won't have to worry about it. Okay, so if you're using the power supply off the Arduino, we know that that's going to be either 5 volts or 3.3 volts. We will be using the 5 volts, and so you wouldn't have to worry about the power supply, okay? But you will have to worry about the resistor. So our resistor that we're going to be using is going to be a set resistor. Now, our calculations are saying that our resistor should be 300 ohms, which is what the ideal resistor value should be for one LED. What I'm going to say, because a whole lot of different factors goes into which resistor you will be using. There's a tolerance factor and everything. What I'm going to say that we're going to be using is actually going to be a 1K or 1000 ohm resistor. That gives us some room to move and be comfortable with, and that way we all have the same values we'll be working with the 1K 1000 ohm resistor, and then we'll have, of course, a 30 milliamp LED and the Arduino. And like I said, if you have it powered with the USB cord, that will be fine, because that is what we're going to be using, is the Arduino. So we want to get away from using 9-volt batteries or the other power supplies unless you have it set up some kind of different way. I'm suggesting that you set it up by hooking up your Arduino to your computer. Okay, so with that said, we're going to go ahead and cut this video short. Practice some of these calculations as far as with the Ohm's law. Okay, practice some of these calculations, because like I said, this graph will cover any situation that you should find yourself in when you're trying to calculate what you should use and the values that goes with it. So I will write this down somewhere. If not all of this, I would at least write this down somewhere for quick references, because working with the Arduino and the power supplies and electronic components, you're going to be calculating some values that you would need to use with the components in order to make sure that everything is balanced. Okay, don't be scared off by that. Just keep going forward. When you're working on things with electronics and prototyping and projects, and especially dealing with different boards like Arduino or the Mega or the Leonardo or what have you, you're going to run into some roadblocks. But the fun thing about it is when you break through those roadblocks and get everything going the way it's supposed to go, then you wind up with something that you made yourself. And electronics can be very rewarding if you could get bitten by that electronic bug. That's a really good thing to be bitten by. So I'm going to leave you here, and I will say check out my next tutorial. Have a great rest of your day. Bye bye. I am Ebony Geek, and I hope that the information provided has been helpful to you. Please remember to subscribe. Happy building and happy coding.